This unit we're going to talk about polygons. So we're going to start big, broad with polygons, and then we're going to learn and get more specific as we go on, and ultimately we're going to focus on quadrilaterals. But to start, we're going to talk about polygons. So a polygon first is a two-dimensional figure that is made up of line segments, and it's closed, which means if you were to walk around the shape from point to point, then you would end up back where you started. So there are different kinds of polygons. So let's first talk about the different types of polygons. So first we have a triangle, which has 3 sides. We have a quadrilateral, which has 4 sides. Quad means 4. Penta means 5, so pentagon has 5 sides. A hexagon has 6 sides. A heptagon is also called a septagon, but a heptagon has 7. That one's new. An octagon has 8 sides. A nonagon like 9, and a decagon has 10. An 11-sided figure is an ungon or a hengon, and a 12-sided figure is called a dodecagon. Anything more than that is just called an n-gon. 15 sides is called a 15-gon. Now, we want to figure out, here's what we want to know. We know that the sum of the angles of a triangle add up to 180. One triangle, we know that these 3 angles add up to 180. And everything we do is going to be based off of that fact right there. So we want to find the sum of the interior angles for all of the different polygons. So in a quadrilateral, if you were to draw in this diagonal, a diagonal goes from corner to corner. Well, what I know is that those 3 angles add up to 180, and these 3 angles add up to 180. Well, those 6 angles all together make up the 4 angles of the quadrilateral. So there are 2 triangles in that quadrilateral, and what we find out is that those add up to 360 degrees. So if we do the same thing, let's follow that same pattern. Let's draw in all of our diagonals from this vertex. I have 1 triangle, 2 triangles, 3 triangles. So when I have 5 sides, I have 3 triangles. Each of those triangles is worth 180 degrees. So if I take 3 times 180, I get 540 degrees. So all of those angles, all of these angles right here, these interior angles, each one of those angles adds up to, all together, they add up to 540. So we continue from this vertex. If we draw across, we get 1, 2, 3, 4 triangles. 6 sides, 4 triangles. So notice, 3 sides, 1 triangle. 4 sides, 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. So 4 triangles at 180 degrees apiece is 720 degrees. So all of the angles on the inside of the hexagon, all of these vertices right here, those interior angles add up to 720. Now, if we continue this pattern, then what we find is that every time there are 2 fewer triangles than there are sides. So if there are 7 sides, then there will be 5 triangles. Each of those triangles is worth 180 degrees. So if there are 5 triangles, then there are 900 degrees inside that 7-sided figure. An octagon has 8 sides. If there are 8 sides, then there are 6 triangles. Each of those 6 triangles is worth 180, which means that there are 1,080 degrees inside an octagon. If we continue, 7 sides in a 9-sided figure, which means that a 9-sided figure has 1,260 degrees inside of it. And a decagon has 8 triangles, 10 sides, 8 triangles, and so 8 triangles at 180 degrees apiece is 1,440 degrees. So each of the angles, all of the angles inside in a decagon would add up to be 1,440. So if we follow that pattern, if we take the number of sides, n, and we subtract 2, then that gives me the number of triangles. And then the number of triangles times 180 gives me the sum of the interior angles. So if I want to find the sum, okay, sum means all of them total. So total if I want to know what all of them are, then I take the number of sides and I subtract 2, because that gives me the number of triangles. And then I multiply that by 180 degrees, and that gives me what all of them add up to be, the sum of them. Now, if I wanted to know one of them, as long as it's a regular polygon, so regular means all the sides are equal and all the angles are equal or congruent. All the sides are the same and all the angles are the same. That's what a regular polygon is. They don't have to be that way, but in this case, to find one of them like this, you would need to know that they are all the same. So if they're all the same, we can take the sum of all of the angles, which was n minus 2 times 180, and divide it by the number of sides. So basically what we want to do is we want to take the total and divide it by the number of sides, and that would give me one angle, okay? One angle. So one way gives me the total number, okay, and one way gives me one angle if all of the angles are the same size. So let's look at that. We're going to work through the odds. The evens are going to be your homework, and so you can work through them on this worksheet and then record your answers in Canvas. So we're just going to work through the odds. So we want to pay attention to whether we want the sum or whether we want each. That's what we're looking for, sum or each, okay? So sum, or do we want one? So find the sum of the interior angles of a 15gon. So for a 15gon, the number of sides is 15. The number of triangles is n minus 2, so there are 13 triangles. Each of those triangles is 180 degrees. Now you can use the formulas if you want, n minus 2 times 180, but I think sometimes it's easier just to understand the process, understand what's going on. So we have 2,340 degrees as the sum, all of the 15 angles in a 15-sided figure. What is the measure of each interior angle of a regular pentagon? Well, in order to know that, we need to do the total divided by the number of sides. Well, that means I need to know the total. If you want to use the equation, remember it's n minus 2 times 180. That gives me all of them. So that would be 5 minus 2 times 180, or 3 times 180. I'm writing out all the steps, but you don't have to do that all the time. So that's 540. So then we come over here and we do 540 divided by, if it's a pentagon, it has 5 sides. So you would divide by 5. So 540 divided by 5 is 108. I didn't leave myself very much room for this. 108. So each angle, each of the 5 angles is 108 degrees. So if you want to find all of them, you find the number of triangles and multiply by 180. If you want to know one of them, you find the total and then divide by however many sides there are. Now, there is an exterior angle sum also. If we were to go through all of this process right here, exterior, so exterior is these angles right here. These are our exterior angles. And these are our interior angles. Now, if you remember, your interior and your exterior, they are adjacent and they are supplementary. They are called a linear pair. So your interior plus your exterior is a linear pair, which means they add up to 180. So if you go in and we find all of our exteriors, so if I do 180 minus 61, I get 119 degrees. If I do 180 minus 79, I get 101 degrees. And if I do 180 minus 40, I get 140 degrees. If I add all of those up, I get 360 degrees. If I continue and I do that for all of these, then that exterior angle is 82. This exterior angle is 59. 87's exterior is 93. 130's is 50. And 104 is 76. Now, notice I have more angles, but they're all smaller than they were with the triangle. But if you add them all up, you know what you get? You still get 360. And so that's what happens is the more sides there are, the smaller the exterior angles get, the bigger the interior angles get. If you were to continue that, so the sum of the exterior angles of a quadrilateral are going to be 360. The sum of the exterior angles of a hexagon, 360. The sum of the exterior angles of any shape, okay, is always 360. So that's what we can learn from this. The sum of the exterior angles, the outside angles, is always 360 degrees. Where the interior changes as your shape gets bigger and gets more sides, your exterior, those angles get smaller and smaller, and they always add to 360. This is extremely important and very useful for what we're doing. So what is the measure of each exterior angle? Each exterior angle of a regular hexagon. We need it to be regular because that means they're all the same. Well, again, we need the total exterior divided by the number of sides. Well, the total exterior is always 360. That's why that's nice, because it never changes. So 360 divided by 6 would mean that each exterior angle is 60 degrees. Now, this is where this is useful, because if you wanted to find the number of sides, then doing it using the interior angles is hard because the interior angles always changes. But since the exterior angle always stays the same, if I give you an exterior angle of 12, how many sides does it have? Well, again, the total, remember if we do the total divided by the sides, that gives us each. Well, I know each. So each was 12 degrees. The total is always the same. It's 360. So what that gives me is if I take 360, the 360 degrees, let me erase all of this so I have more space. If I take the 360 degrees that I have and I divide it into 12-degree increments, then I am going to get that there are 30 sides. Okay, 30 sides. So that makes it really easy. So I took the 360 degrees, I divided it into 12-degree increments, and that means if there are 30 angles, there are 30 sides. Now, what if I gave you an interior? Okay, so if I gave you an interior angle is 108 degrees. Then and I ask for how many sides? If I ask you for how many sides, then here's what you got to do. I know that anytime I want to know my number of sides, always use exterior. So exterior is 360. Okay, 360. But I have to divide exterior by exterior. And the problem is I gave you interior. Well, if interior is 108, then exterior, remember those are a linear pair, is 72. So I can divide 360 degrees into 72-degree increments and get that there are 5 sides. Okay? So if I ask you for the number of sides, always use the exterior angles. Even if I give you the interior, but you have to do exterior divided by exterior. Okay? So let's look at number 10. If the exterior angle of a regular polygon it measures 9 degrees, then how many sides does the polygon have? Again, I gave you an exterior. Anytime I want to know how many sides, always use your 360-degree exterior. So 360 degrees divided by the into 9-degree increments says that there are 40 angles. If there are 40 angles, then there are also 40 sides. Okay, so number 12, find the value of x. Well, in order to find the value of x, I need to know what all of those angles add up to be. Well, I know the easy way with quadrilaterals, just memorize. Quadrilaterals equals 360 degrees. So then I would say 79 plus 55 plus 110 is 244. So I've used up 244 of my 360 degrees. So if I take 360 and subtract 244, I get that the leftover, the x, is 116 degrees. Now, for number 14, I want to know what x is. Well, in order to do that, when I did it with a triangle, I knew triangles added to 180. I know quadrilaterals add up to 360. What I don't know off the top of my head is what does this 1, 2, 3, 4, 5, 6-sided figure add up to be? That's where you got to go back to your sum of your interior. Okay, so you need your total interior so that you know what to set it equal to. So remember, it was n minus 2, the number of sides, minus 2 times 180, because it's triangles times 180 degrees. And 4 times 180 degrees is 720. Okay, so all of these angles add up to 720 degrees. So here's what we want to do. We want to go ahead and we want to combine our like terms. So I'm going to do 6x and 8x and 5x, 7x. So 8 plus 6 plus 5 plus 7 is 26. So I have 26x, and then I'm going to add 110 minus 1 plus 36 plus 116 plus 19 minus 2. So just work your way methodically around the circle and add and subtract those numbers. And you get 278, so positive 278. And all of that should equal, the total of all the angles should be 720. So subtract 278 from both sides. So 720 minus 278, and we get that it's 26x is equal to 442. And we get that x is equal to 17, which is what I asked for, so that's my final answer. Okay, now again, I want to find angle B. To find angle B, I need x. Okay, I can't find B until I have x. To find x, I need the total. So remember quadrilaterals, easy, just remember 360. We don't need to do the n minus 2 times 180. Just memorize that quadrilaterals add up to 360. So let's combine our like terms, 8, 5, 10, and 14. That's 37. So 37x, and then we have positive 7, positive 18, minus 11, plus 13. We get 27. That equals 360. It's so hard not to say equals 180 because that's what we're used to saying. Subtract 360 minus 27 and you get 333. You get that x is equal to 9. Now I asked for angle B. So to find angle B is right here, 8 times x plus 7. So 8x, now that we know what x is, it's 8 times 9 plus 7, which is 72 plus 7, which is 79 degrees. So angle B is 79 degrees. Now 16, on 16, the figure below is a regular polygon. So regular means all of them are the same. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. Here's the thing. I need to know what one of those angles is. It's regular, which means all of them are the same. So there are 10 angles that are all the same, but I don't know what they all add up to be yet. Remember how to find the total interior. 10 minus 2 times 180. Okay, so 8 times 180 gives us what all of them should be. So that's 1,440. So all of them should add up to 1,440. But I just want to know one of them. So one of them, if I take 1,440 and divide it by 10, one of them should be 144 degrees. Okay, so if that's the case, 144 degrees, that means that 10x plus 4 is equal to 144 degrees. So subtract 4 from both sides, you get 10x is 140, or x is equal to 14 if you divide both sides by 10. Here's a hint on number 17. These are all exterior angles. And we just talked about, remember, all exterior angles add up to 360. Always. It doesn't matter how many sides there are. So if you want to know the sum of the interior, we go way back. The sum of the interior is all of them. Find the number of triangles, which is sides minus 2, and multiply that by 180. If you want to know what one of them is, find the total and divide by the number of sides or angles. And then exterior angles always equal, the sum of the exterior angles is always 360, regardless of how many sides there are. And then one last thing is, don't forget, the interior plus the exterior equals to 180 because they're a linear pair. And anytime you want to find the number of sides, use that exterior angles, because that's the one thing